Let's look now at a specific case of the fourth industrial revolution, which are the smart factory. If we look at what the smart factory involves, you will see by definition that it's all about the connectivity between the machines and the robots, the database, computers, and private cloud of the factory, so that there is an overview in real time of the production with the different criteria of evaluation for accountability and for productivity efficiency that is available either on the floor or at a much higher level, or even if you can consider to an international level where you would have several factories and you would be able to compare their productiveness in real time between each other. As well, for instance, maybe realize that some have downtime when others have uptimes, and see how you can actually compensate and make your product more efficiently produced, which will in return will make it cheaper and increase your market, as you can make it available for lower price. So here's some example you can see, like with a very famous Tesla factory chain line. Now, as well, I would like to point out the mobile robots that allow to distribute some gears to people or to the shelves, like these links from Omron on the bottom left, of the PowerPoint slides that you can see there. Another advance for the smart factory is collaborative robots, and here you have an example of universal robots, collaborative robots, where basically you don't need all this extra safety around it. It has several effects to do so. One, it's reduce the footprint of the robot itself. The second advantage of it is that you can move the robots around much more easily from one task to another. You can potentially even put it on wheel, on links, for instance, so that it's actually mobile around the factory. Another advantage is that, of course, human can work next to it without any risk to be injured. And finally, the setting cost it's much lower, as there is much less sensor and safety to program, much less hardware to add, and so it decreases and the hardware cost and the labor cost of such installation. Now, when you look at a wall, the factory, you can imagine that you will have something that goes from the raw material delivered through trucks in the loading zone using automated forklift such as NDC forklift. You can basically unload the trucks, store the packed raw materials on the shelves at a specific place, having as well shelves that can stack to each other, basically providing the little robot that is on the rail of the shelves and store the package as they come, and book the inventory, so know everything where they are, send all those data to a database. And as well, like when the raw material are indeed needed, you can get the forklift, request such material. The automated shelves, which save such a footprint already by being compacted, extract the requested pallets of raw material. The automated forklift that basically take it off from the shelf, put it on a chain line that would undo the package, basically the same way that you would do the package and do palletizing, but in reverse. So then you will have the destacking of the smaller pack from the pallet, putting in a process where the pack will be cut out, and there is some machinery of the shells that does that, cutting around the part of the cardboards around the package, and then have a system to dig in. So then after, depending what it is, if it's more powder or soluble type of things, or granular, such as pallets of plastic or whatever the product need to be made of, or it could be aluminum rolls that are installed on a roll forming machinery. It can be quite any type of raw material, and the process will depend on what the nature of the raw material is. In any case, this will allow loading automatically of the raw materials to the production machinery to develop the actual product. And once that is made, you get all the different parts of the chain lines and can basically check the state of the product fabrication, potentially with microchip RFIDs that are so cost effective that you could implement them on each product to survey them on all the process of their fabrication. And once that's done, you can palletize the product, store it, and eventually when the truck for loading and delivery of the goods is arrived, you can directly load it into it. Those are things as well with a smart factory. Doesn't have to be necessarily nobody on the shelves, right? On the floor, I mean, of the place where the product is manufactured. It can as well include human being interacting with the machinery in a much smarter way, where you have a direct monitoring with some graph of what's doing what and what require certain attention with an order of priority. So to resume, it's about automatizing the whole process from the web, for instance, where you could order a pair of shoes from Nike, which have developed this type of smart factory, for instance. Any type of basically e-commerce, where you will order with really customized options your products, and this information will be transferred to the factory on main computer servers that will harvest all the orders and then distribute them to the processing queue of fabrication to the production floor. And as well store all the data, give some update information about where the product is, at what stage of production and how long it will take before it's arrived to the door of the customer. And all that it's about large data that get harvested, modified, configured, mined to so that you extract the relevant data for the production, for the efficiency of the products, and so forth, with great software and human-machine interface that allow this nice interaction between human and machine, human and human, machine and machine. And all that's what it's about: connectivity, Internet of Things, or in this specific factory way, Industrial Internet of Things, IIoT, which is becoming a trending word nowadays. So this as well, for instance, if you use or run services, as you can see, there's a lot of things available already on the market to implement smart factories. And so where there is a highly critical safety-oriented communication between the machinery, you can use the protocol Ethercat. And then where it's all about connectivity through the web and the office and the different factories, then you can use the classic Ethernet TCP/IP connection. And Omron have a fantastic system there where you can communicate between the machine on the floor where there's critical process to be implemented in real time, and the more software oriented Windows type like machinery, which is not reliable in timing and things like that, but more used to have a nice graph and interface and understanding of the production cost and things like that, then you can switch to the Ethernet TCP/IP protocol. So if we sum up that and we say, well, the client give an order through the net, send the data to the factory. The factory have automatically order depending on the forecast and previous prediction of production, the raw material it needs and what it's have in stocks, so that there is an optimal system between storage and order according to the previous order you can do over several years, and the trend of increase or decrease as it comes, so that you get an optimum amount of raw material, so you never are short or have too much cash flow involved into this raw material cost. So the raw material get distributed to the factory, automatically unloaded, stored in smart shelves, and when it's required, it's picked up from those shelves and put into the process of making the raw material, first by unpacking the raw material and then by producing the product with all the custom information that are stored with. You can look at some QR code, barcode, RF information, where each product have its own identity and will be built differently according to the requested option that the client have entered in the e-commerce stage. Once the product is made, it's packed up and then put back in storage into the smart shelf through the automated forklift. And then once the delivery truck arrives, then the forklift can easily put from the smart storage to the delivery truck the crate, the box, depending on what type of level of quantity we are speaking of. But we can imagine that the trucks go to a sorting factory which deal more with mail, and nowadays it's already fully automatized, where you get sorted all the different mails towards different area to where the goods need to be sent. And then a package arrives to the customer. Customer can give some feedback, and the loop is complete. So here's some example of NDC automated forklift that can be used for diverse applications, such as crates, such as roll forming, aluminium or paper rolls, and so on. So there really is a good variety already of forklift that can safely work into the environment, go around, know where they are, and can work in collaboration as a swarm of units, depending on the task required, with developing optimum path. Here's another example of AGV that is presented by Omron, where it can by itself all charge load up to 90 kilo. As well, if you put the reinforcement system, you could go up to 150 kilos. So that's quite substantial, and you can install, as you can see, some conveyor. So you can convey a box from one unit to another, go from one level to another if needed be. You could control elevators and doors, so the system can go from one section to another and provide goods. Same thing if you require some manual testing, things like that. You can get this Lynx AGV to get the required parts in a shelving system, and then it can be transported to wherever you need to go. So as an example, you can look at this smart shelving that, depending on the order of the automated forklift, organize itself and let know where there is a free space and where the person can go around and actually monitor all what's available as raw material and things like that. There's another stackable shelf example. There's different sorts, as you can see, some on rails, some have just a little conveyor that drive through around the rail and place the pallets one done at a time. It really depends on what you are storing, and according to what you're storing, you can look at different type of shelves that will basically stack with itself and will save you at least double the space because of the compactness of it. Here's some other example of collaborative robot with a universal robot that we are distributing here with molding extraction, sorting, packaging, palletizing, many diverse type of application. Another really useful robots for high speed and sorting is the Quadro from Adept or Trio, as well labelers. We use Matthews to labels also products, which most of products have label to be applied. So each application is different, and we can customize the way it goes, and so basically totally automatize the labeling process as well. Then you go to the packaging, so there's a pre-packaging sorting machinery, you have pallet wrappers, you have box closers, box formers, pallet destackers that distributes the pallets itself. Yeah, as an example of a picture from Amazon factory, where you get all those little different units that go under the shelves, raise the shelves, and move them around depending on what's needed to be done and how it needs to be sorted. There's a high level of units, so much different type of things that need to be conveyed from one spot to another. So that's the solutions they went to it to totally automate this place. So that gives you a bit of a flavor of what type of product or a smart factory system can be conceived, and a bit of off-the-shelf demonstration of what you can find on the market, and a lot about getting all the system connected together, and that's what we can help you with.